In this problem, we're told on a frictionless horizontal error table, puck A with mass 0.250 kilograms is moving toward puck B with mass 0.350 kilograms, which is initially at rest. After the collision, puck A has a velocity of 0.12 meters per second to the left, and puck B has a velocity 0.650 meters per second to the right. A, what was the speed of puck A before the collision, and then calculate the change in the total kinetic energy of the system that occurs during the collision. So let's go ahead and start with a drawing, because that's how you always want to start these problems. So we're going to draw what happens before and what happens after the collision. Okay, so before the collision, we have two pucks, right? So one's going to be at rest, right? So imagine this is the puck at rest. So here's our puck at rest. Its mass is going to be, this is puck B, right? So its mass is 0.350 kilograms. We know it's at rest, and then puck A is going to be traveling towards it, right? So imagine this is puck A, right? So here's puck A. It's going to be traveling this way, right? With some velocity, right? We can call it v sub a. We don't really know what it is yet. And it's going to have a mass of 0.250 kilograms. Okay, so we have this puck. It's traveling. It's going to hit this one standing still. That's before. And then so let's do the second one. So after the collision, puck A is going to have a velocity, right? So let's label both the pucks. Here's our puck 1. And then puck 2. This is B, right? So A is going to have a velocity of 0.12, right? So 0.12 meters per second, and it's going to be traveling to the left, right? So to the left, and I'm going to label it negative. So when we do problems like this, generally you want to say the direction, right? You specify the direction with a negative sign. So since it's going to the left, we say it's negative. To the right would be positive. Okay, and so puck B is going to be traveling to the right, so its velocity is going to be positive 0.650 meters per second, right? And so the masses are going to be the same. Nothing changes about that, right? Okay, cool. Right, so this should be everything. Okay, yeah. So this is going to happen. It's going to hit it, and then this one's going to go this way. This one's going to go this way. So what do we want to do now? So the way we're going to solve this problem is by using the law of conservation of momentum, right? Which essentially tells you the momentum before has to be equal to the momentum after. And the way we're going to do this, right, is we're going to say just this is the formula we're going to use. So m1v1 plus m2v2 is equal to m1v1 final plus m2 v2 final, right? So essentially, we know momentum equals mv, right? P equals mv. This is momentum. So we know the momentum of the first two objects in the beginning is equal to the momentum of the second two objects at the end, right? And so what we're going to do is plug in the variables for each of these, and then we're going to be able to solve. Okay, so when I say 1, essentially what I'm talking about is a. So I could write a, but I'm just going to keep it as 1. But essentially, just keep in mind that 1 represents a, and then 2 is going to represent puck B. So just keep that in mind. We can label that, right? So 1 and 2. Okay, so let's write down each of the things. So we know M1 and M2, right? M1 is A, right, which is 0.250 kilograms. M2 is going to be B, which is 0.350 kilograms. These don't change throughout the problem. The things that are going to change are the velocities. So this is V1, this is V2, this is V1 final, and this is V2 final, right? 2 is B, 1 is A. So we want to label each of these so we can actually solve. So let's write those down. So V1, V2, V1 final, and then V2 final. What's V1? So V1 is going to be velocity A, which we don't know, right? They don't tell us that's what we're solving for in the first part. So let's write question mark. V2, the velocity of puck B before it gets hit, it's not moving, right? They tell us it's at rest, therefore its velocity is 0. So 0 meters per second. Then let's look at this one. So V1 final, after the collision, it's going to be 0.12 meters per second, right? But since it's going to the left, we want to label it negative, right? So V1 final minus 0.12 meters per second. What about this one? So this is going to be puck B after the collision, which is 0.650 meters per second. And since it's going to the right, we label it positive. So now what you should see is we have every variable. And so you can just go ahead and plug in. That's what we're going to do. So let's go ahead and do that. So M1 is 0.250 multiplied by V1, which we don't know, we're solving for, plus M2, which is 0.350 times V2. But notice V2 is 0, right? V2 is 0. So anything times 0 is going to be 0. So we can really ignore this one. So we can just set it equal. M1 is 0.250 again, times V1 final. So V1 final is minus 0.12, and then plus M2, which is 0.350, and then we want to multiply that by V2 final, which is 0.65. So what you should notice here is we can just go ahead and solve, right? V1's by itself, we can solve for it. So let's go ahead and add these up. So go ahead and plug this in your calculator. You want to do 0.250 times minus 0.12, and then add that to 0.350, right? Plus 0.350 times 0.65. Yeah, so when you do this, you should get 0.1975, right? So 0.1975 is going to be this side, and then if we want to solve for V1, you just want to divide, right? Just get V1, and when you do this, right, so do 0.1975, divide that by 0.250, you're going to get 0.79, right? So 0.79 meters per second. This is the velocity. And then keep in mind, since it's positive, what does this tell us? It means it's going to the right, because we labeled the right positive and the left negative. So 0.79 meters per second to the right, right? And what was V1? Remember what it was? It was A, right? So it's the velocity of the A initially. So that's what we just solved for, right? So this is your answer to A. So A was the speed of puck A before the collision, which was V1. So 0.79 meters per second to the right. So this is your answer. Let's move on to B. So what's going to be B? So B is going to be calculate the change in the total kinetic energy of the system that occurs during the collision. So how do we calculate the change of something? What we want to do is take a look at the kinetic energy initially, and then the kinetic energy finally, and then we can subtract, right? Because that's going to give us the change in it. So let's calculate the kinetic energy before the system and the kinetic energy after the system. So to do this, you should know the formula for kinetic energy, 1/2 mv squared. If you don't know this, write it down. But this is the formula for kinetic energy, and we're going to use this to solve. So let's start with the kinetic energy before. Okay, so we're going to call it KB for kinetic energy before. So think about what it is. It's 1/2 mv squared. Okay, this one's at rest. So the velocity for this puck, right, because we got to add them both up. So we're going to add this puck plus this puck, the kinetic energy of both of them. Keep in mind, though, this one's 0, right? So what does that mean? Its velocity is 0. Therefore, the kinetic energy is just 0 of this puck. So we really just got to take the kinetic energy of this puck. So it's going to be 1/2 mv squared, right? That's the formula. So multiply it by the mass of the first puck, 0.25. And then we multiply by the velocity of it, right? We just solved for that, 0.79. So 0.79 squared, right? It's just 1/2 mv squared. So do 0.5 times 0.25 times 0.79, and then you want to square that. So yeah, 0.5 times 0.25 times 0.79 squared. Yeah, so when you do this, you're going to get 0.0780125. Yeah, so keep in mind, kinetic energy, we measure it in joules. So this is it in joules. Now let's do the kinetic energy after. So this one, they're both moving, so we don't get one to cancel out like this one, but we can still solve. So 1/2, and so let's start with the first puck, A, times its mass, 0.25, times its velocity, which is minus 0.12 squared. The negative doesn't really make a difference since we're squaring it. You can include it or not, doesn't make a difference. So plus 1/2, now we're doing block B, so 0.35. And then we multiply it by its velocity, so 0.65 squared, right? So 1/2, 0.25. Yeah, so this is correct. So let's just go ahead and plug it in. So 0.5 times 0.25 times 0.12 squared, right? Because it's going to be positive or negative, plus 0.5 times 0.35 times 0.65 squared. Right, so when you do this, you're going to get 0.0757375 joules. Okay, so it's going to go from this to this, and what you should notice is it's a smaller number, right? We're losing some kinetic energy during the collision. So what we want to do is we want to find the difference, just subtract the two. So take the final minus the initial, right? So just take this number and then minus this one. So 0.0780125. Yeah. So go ahead and do this, right? So minus 0.0780125. Right? So when you do this, you're going to get minus 0.002275 joules. Right? I'm going to round just to 0.0023 joules. Right? So 0.0023 joules, it's negative, right? Because we're losing it. So the change in the total kinetic energy is going to be this, right? We're losing 0.0023 joules. you can have the negative sign. I guess the change in the kinetic energy would be the negative, but the amount we're losing is a positive number, right? Because you're not losing you can't lose a negative number, right? That would be gaining. But yeah, so essentially the change in the kinetic energy is minus 0.0023 joules. This right here is going to be your answer to B, right? So 0.79 meters per second to the right was your answer to A. This was your answer to B. And yeah, so these are answers, and hopefully you found this useful.